Good morning. Let's get into 6.2 notes. Looking at this, we've got our vocabulary. A square root function is a function written as, and we'll zoom in. Maybe we won't. Will we? It doesn't allow it. Okay, so we're just going to say a, then the square root, x minus h plus k. So the domain of a function is all the x values. And in this case, it's going to be h to infinity, which is very interesting because remember, you can never have a negative number inside the square root. So if x was the value h, inside the square root, it would be h minus h, which is 0, and 0 is allowed. And the range is going to be two things. So it's all the y values, but specifically k to infinity, including k, or negative infinity until k if we have a negative a value. So if a is negative, that means that we reflect over x-axis, reflect. And you'll need to fill this in according to what happened in 6.1. You should have all that refresher information. I just want you to fill it out again on your own. And then we're going to specifically look at creating the parent function. So the parent function for this is just the general square root function. And that means that we are plugging in just to the square roots. This one's probably going to be the fastest parent function since we've done so much square root work recently. So the values for x are going into the square root of x. So as you know, if you plug in -2, you get error, right? If I plug in -1, that's I. These are values that are not allowed. Okay, this is not what we're doing. So what we are going to do is select values that make sense for us. So we're going to select the smallest number that you think of. And hopefully you thought of this number, but maybe you didn't. It's 0. The square root of 0 is 0. The next perfect square number is 1. The square root of 1 is 1. So these two are really cool. They are reflexive. They are their own answer. The square root of 2, no, that's not it, because that's not going to be a whole number answer. That won't be easy to graph. So we're going to go right to 4. The square root of 4 is 2. Then we'll go to 9. And the square root of 9 is 3. If I went to 16, then I'm going to be off the graph. So then when I plot these, it's going to look really weird because this graph includes no negative values. So I start at 0, 0. I go to 1, 1. Then I'm going to 4 for x, 2 for y, 9 for x, which is right before 10, and then 3 for y. And I do not include any negative values, but I could imagine that the next value would be 16 and then 4. So I'm going to draw my arrow heading off to the right-hand side of the graph. So we connect these, and that's what we get. It looks really good. So the domain for this function is going to be from 0 to infinity. And we have the hard bracket at 0 because it's one of the specific ordered pairs. We're going to use the soft brackets on infinity and then excluded values like asymptotes. This time the range is also 0 to infinity. The x-intercept is 0, 0, and so is the y-intercept. We'll look at solving those on more functions. Let's take a look at an example where it's not just 0, 0, and an a value of 1. Okay. I'm going to have you write in the steps to graph over here as a summary that you will be graded on. So I want you to come up with what you think the correct steps are on your own. Ooh, challenge, right? So I'm looking at this function. We see the blank space. That's going to be the work area where I'll find the x and y intercepts. I see that the a is the 3. The h, it looks like plus 6, but it's going to be minus 6. And then the k is minus 4. So because we have a, I'm going to graph all of these the same way that I did before. So the same way that we graphed the reciprocal function. I'm going to go to -6, -4. -6, -4. I'm going to pretend that that's the new origin, and that's going to help me. That way I only have to make the easy table for this parent function. So I'm going to have x, then I have 3 times the square root of x. And so I'll often think of that as times 3 over here. So if we think of our parent, the values we plug in are 0, we get out 0, 1, we get out 1. I want to say 2, but it's not 2. It's 4, we get out 2, and then 9, we get out 3. And then I'm going to multiply these all by 3 to get my correct final y value, which with an a value of 3 is a stretch by 3. So that's going to be 0, 3, 3 times 3, 6, 3 times 3, 9. And then I want to cross these y values out because those were just like part of my work. You don't always have to show that work, but I wanted to show the work. And then we're going to plot from the origin. Oh, my new HK origin. So I am at the HK, I'm at that 0, 0 point. Then I'm going to go 1 for x, and then up 3 for y. Check. I'm going to go over 4. 1, 2, 3, 4, and then I'm going to go up 6. 1, 2, 3, 4, 5, 6. And then we're going to go over 9. So this is 6, back to the y-axis, 7, 8, 9. And we're going to go up 9. So this is 4. 4 plus 5 is 9. Cool. So the comparison I'm going to do now is going to be comparing this one to my original. So the original is over here. And then this is the new transformed function. So I'm going to look at listing my transformations. So the a value of 3, it's definitely taller, and we're calling that a stretch by a factor of 3. Then I'm going to describe the left and right shift. So we can imagine this getting stretched by 3 first, right? And then we moved it this direction. So that's left 6. So shift left 6. And then for the k value and down 4. Cool. So let's take a look at the domain. So the domain is all the x values. The first x value that we meet is this x value along this not vertical asymptote, but just like a boundary line to help us graph. And that's going to be -6. And then we see that the arrow is pointing towards positive infinity for x. So that's great. And then the range is also heading up towards positive infinity for y. It starts down at -4. And then the x-intercept and the y-intercept, I can see that, yes, it does cross at different places, but I don't know the specific values. So I'm going to do the work. So replacing y with 0, I add 4. And then I have 4 over 3, I divide by 3, is equal to the square root of x plus 6. So hopefully you see that I isolated that square root. Then I'm going to square both sides. Squaring both the 4 and the 3 gives me 16 over 9 is equal to x plus 6. And then I subtract 6. So that's a little bit messy. I am going to use a common denominator. So let me erase this so I have my space back. So -6 is going to be the same as over 9, -54 over 9. And I'm adding that with 16 over 9. And 54 minus 16, oh man, I have to borrow. 4, 14 minus, okay, 8. 4 minus 1 is 3. So since the 54 is bigger, this is going to be -38 over 9. Or -4. 4 goes into 9 goes into 38 4 times, which would be 36, and then there'd be 2 left over and 2/9. So that was the x-intercept. I'm going to write it as -4 and 2/9, comma 0, and then I'm going to look on my graph to see if that makes sense. So -1, 2, 3, 4. Oh, and then just a little bit more. That seems reasonable. The y-intercept, it's going to be really easy. I'm just going to plug in 0 for x. So that's going to be 3 rad 0 plus 6 minus 4. And because there's no 6 that I take the square root of easily, I'm going to leave it. So since it's -4, I'm going to write the -4 first. So I'm going to write 0, comma, -4 plus 3 rad 6. And that's it. All right. These are fun-ish. Cool. Number 2, I love this one because we get to see how does the negative sign affect this. So the a value here is -1, the h is +4, and the k is +9. So I'm going to begin by plotting the 4 for x, 9 for y, 9 for y. Okay, that's all the way up here. And then I'm going to sketch these new lines to pretend like that's the new origin. And then I'm going to make the table that's x, square root of x, and then I'm going to have the times by -1, which is the a value. So I'm going to have 0, 1, 4, and 9, 0, 1, 2, and 3. So here now I've done it 2 times, it was easier. And I multiply these y values by -1, which gives me 0 still, -1, -2, and -3. Goodbye to these ones. So now starting at my new coordinate of 4, 9, I'm going to plot, I've got 0, 0, check. 1, -1, so I move over 1 for x and down 1 for y. So now it kind of makes sense that we're way up there. Going to move over 4 for x. So I was at 4, now I'm going to be at 8, and I'm going to move down 2 for y. 1, 2. And then if I moved over 9, it looks like I would be off the graph. See, this is 4 plus 6 is 10. So yeah, we're way off. I'm just going to draw what matches, but I have to make sure not to pass through my origin. So my domain, as I see it, right? Switch to like a slightly different color. The domain is, I start here and then, hey, weird. It doesn't let me. Oh, it's like not letting me highlight. Let's see, whatever. Okay, so we start at this x value, which is -4. And we see that the function goes to infinity. So I love this. I have the hard bracket on this. Okay, but what about the y? Well, the y value starts up here and then goes down. So that means it goes down to -infinity. So this one is the -infinity until, and it stops at the y value right here of 9. So I think drawing these new HK dashed lines is really going to support us with understanding the domain and range. Love it. Okay, my x-intercept, I didn't see it by graphing, but the y-intercept. That's very interesting. We can answer that right now as NA. Okay, why? Why is it NA? Well, here's my y-axis. And then here's my function over here going in that direction. So I'm never going to go towards it. And that would make sense. The domain, the y-intercept is the coordinate 0, comma, y, which means it would need the domain to include the value 0. I wrote -4. Oh, yay, I found my mistake. It's not -4, that's 4. If it had been -4, 0 would have been between -4 and infinity. Oh, well, I hope you saw that mistake before I did. Anyway, to find the x-intercept, we do the same work that we did previously. I'm going to isolate the radical. So I'm going to subtract 9. I've pretended that this is 0 minus 9. Then I divide by -1, which is great. Because remember, we can't have the square root equal to a negative, but looking at this, it does look like eventually it will cross the x-axis. So it's going to be -9 divided by -1 will be +9 is equal to the square root of x minus 4. Then I square both sides and I get 81 is equal to x minus 4. Adding 4, I get 85. So that's going to be 85, comma 0. And the transformations, we start with A, which was a reflection over the x-axis. Then we look at the H, which was right 4 units, shift right. Oh, shift right 4. And then we went up 9. Great. Okay. Let's look at our error analysis. So in this case, we see, first of all, that we have the correct parent t-table. Okay, then they're using the AY table, but I definitely see the mistake. This is a -2 and this is a +2. So what can I do? What can I do? They have the +1. So if I sketch this at -5, comma 1, my A value should be -2. Okay, that is going to change the range and the x-intercept and the y-intercept. Well, let's see if maybe they did their work for the y-intercept correctly. Got negative. Let's see the work for that. So here's the work for the x-intercept. And I'm looking at the work and it's really good, but then they wrote none. So the work for this x-intercept, -5 plus 1/4, we'll subtract those. So 5 take away 1/4 would be 4 3/4. So there should have been an x-intercept. X is equal to, we see this, -4 3/4, comma 0. Okay, how do we fix it using this strategy? So this is a strategy you could do to get the specific coordinates. It's not different. It's just starting from 0, 0 to get the specifics versus starting at the origin and using the scale. So if I want to kind of do it our way, I'm going to take these y values and times them by -2 and get 0, -2. 2 times -2, okay? 2 times -2, -4. 3 times -2, -6. And then I am going to begin from the coordinate that they've already selected. Here's my 0, 0s. That value didn't change, it is 1. Then I'm going to go over 1 and down 2. 1, 2. I'm going to go over 4 and down 4. I'm at 5, so that's -1 and down 4. 1, 2, 3, 4. And then I'm going to go +9 units to the right. So this is 5. This would be 10, so 9. and then down 6. So I'm at 1, I'm going down to -5. Cool. And so it's the exact, ooh, it's a sideways parabola. So we're gonna say reflect over x-axis. That's always the first thing that we'll talk about for a negative sign, reflect over the x-axis. Then the stretch by a factor of 2 is good. Horizontal shift left 5, good. Vertical shift up 1, I love it. And then the y-intercept, -4 and 3/4. Wait, that's the x-intercept? Is it also the y-intercept? No, that's the x-intercept. Oh, look, they put that in the wrong spot. They had the right answer, but they put it for the y-intercept. I didn't even notice that. Okay, so then how do we find the y-intercept? Gosh. The y-intercept is just plugging in 0 here. We're going to get 0 plus 5, so it's going to be -2 rad 5 plus 1. That looks really messy, so we always move the 1 into the front. So it's 1 minus 2 rad 5, and that's the y value. So this goes here, and then as the x-intercept, and then I'm going to call this the y-intercept, so I'll put 0, comma, and then say y-intercept. Zoom a bit, my best, gee whiz. All right. So that negative sign, it makes a big difference. And then finally, let's find this one. Okay. I'm seeing that the HK is that starting point. That's it. 3 for X, -6 for Y. And then I can see the stretch factor. Can you? Maybe not. So I see a specific coordinate right here. So I'm going to plug this in just in case we can't see it. Y equals A. Oh, I got to put the square root symbol. X minus H, so -3, and then -6. In here, I'm going to replace this coordinate. And that coordinate is 4, comma, -4. Oh, cool. So this is the X value, this is the Y value. I better go slow to make sure I don't make a mistake here and get those mixed up. They're very similar. So -4 is equal to A, the square root of 4 minus 3 minus 6. So you can see here why this -6 on like intercepts, we want to move to the front because I almost slid it inside the radical, which would have been wrong. Okay, 4 minus 3 is 1. Square root of 1 is 1. So we have A minus 6 is equal to -4. Now we add 6. We get A is equal to 2. And that means that my correct and final answer is, let's make it a little thicker. We'll go to black. Y equals A of 2, square root of, and then this is the same, X minus 3 minus 6. Okay, so these, they're not too bad to graph. I want you to write the list of the steps needed to graph the function. Right, in order to write the equation of the square root function, what did we do? And then back up here, in order to graph the square root function, what do we do? You write those in. They should make sense to you. Just write, summarizing the steps, and then you're ready to start on your 6.2 practice. Have a great day.